Okay, and welcome back. So in the last video, we did a brief review of what quantitative variables were, what the process of exploratory data analysis entailed, and then we put them together and we talked about why we do exploratory data analysis on quantitative variables, what it is that we're trying to get out. And now at this point, we're going to go through the 4 different steps of exploratory data analysis applied to a quantitative variable. We did this already for the categorical, and we're going to see for quantitative it's quite different. And so our first step is going to be inspect the data. So what I'd like you to do is to go ahead and open this Google Sheets. If you click on this link, it will open up a new web page, and that's a Google Sheets page. You can go ahead and download the data from the Google Sheets into an Excel file and then import that Excel file into StatCrunch. And if you're not quite familiar with that process or you don't remember how to do it, we have videos on our Canvas course homepage now that will show you how to do different operations with StatCrunch. And there's a short video on that if you need to go back and review it. So go ahead and pause the video right now and do that, and then we'll come back and get back into data cleaning. Okay, so you've gone ahead, imported your data into StatCrunch. Good. And now what we want to do is we want to learn how to inspect and clean that data. So the general idea is that there's 3 things we want to do. First of all, we want to sort the data values. So we can do that in StatCrunch or Excel. Some people prefer to do it in Excel, but actually the commands, really the same commands in StatCrunch. So it's 6 of one, half a dozen of another. And what we want to do is we want to look at really the ends of the data set. Generally, where the suspect data values pop up is in the values that are either really small or the values that are really large. Now, that's not always true, and you have to realize that. There are times when if you have really large data sets, you just can't visually inspect them all. And you'll look at you'll go ahead and sort it, and you'll look at the really small values, and you'll look at the really large values, and you'll think you'll be fine. However, there are 2 types of errors that are more difficult to catch. The first is that you can have errors in the middle of the data set. So suppose you're looking at count data, where you're counting the numbers, say, of children in households. And so you go ahead and you sort the values, and you find that the really low values, you have households that have 0 children, which is possible. And then you have a few households that have really large number of children, maybe 10 or 12, and again, that's possible. If it was like 198, that would probably be invalid, right? But what if you had a value of 4.5 in the middle of the data set? If it was a really large data set, that would be a hard error to catch. How could you catch it? Well, sometimes when you plot the data, you'll see the problem. So if you were to plot the data and you had count data, right, you should see bars at, discrete values, integer values, and you would see a bar at 4.5 and you'd know something was wrong. But there's a second type of error that's really insidious. If a person makes a typographical error, but the incorrect value that they enter is within the range of allowed values. So suppose, for example, a family really had 2 children, but I entered 12. That would not show up as an error. It's possible to have, a family that has 12 children. And so this is an issue. Or if I meant to enter 6, but I actually hit the 7 button, okay, we wouldn't be able to actually identify those unless we knew those individuals, ourselves. So there are some errors that you can't catch, and there's nothing we can do about those. So we go ahead, we identify the values that are suspect, and then we have to figure out whether we're going to do something with them. And the naive and incorrect answer is delete the values. And that is definitely not what we want to do in a lot of cases. And we're going to talk about why and when we do what with certain types of suspect data values. So let's get into the details here. So we recall there are three different types of suspect data values we could come across. We're going to review what they are and talk about what we're going to do with them. So first we can have an invalid data value. And we said that these are data values that cannot happen when we talked about categorical variables. So in the case of a quantitative variable, if you were looking at, say, heights of humans and you came across a person who was listed as 12 feet tall, that's obviously invalid. That can't happen. What do we do with it? If possible, we'd like to go back and correct it. We'd like to figure out what the value should be. And generally, if you're using someone else's data set, that means that you have to contact them directly and talk to them, or the person who is familiar with the data set, and try to figure out what's going on. Generally, if you have a really large data set, you can delete the value and it won't really affect your results. But again, we don't want to do that if we don't have to. Now, there's a second type of invalid data value that did not occur when we talked about categorical data. And that is values that are not from our population of interest. So to give you an example of what that means, suppose you were looking at the prices of bicycles that you pedal and ride. And you were interested in touring bikes. That was your population of interest. But somehow data got in on a dirt bike. That data value is not relevant to your population of interest. And if you use it, you're going to be taking a sample that's not representative of the population you're interested in. So we automatically remove those. Now, that takes care of invalid data values. What about outliers? So we said that outliers are values that are possible but very unlikely. And generally, the reason why they're unlikely is they're very extreme. So as an example, a person who is 4 foot tall would be an outlier. It's possible to have someone at that height, but it's also very unlikely, very unusual. To get someone that is 7 feet 9 inches tall, it's possible, but very unlikely. What do we do with them? We do not automatically delete them. And this is a notion that sometimes students have, and it's very wrong. The only time you can delete an outlier is if that individual is not from your population of interest. So, a quick example. Suppose I'm looking at the ages of people in a nursing home, and my population of interest is the residents of the nursing home. And somehow there happened to be a young kid who was visiting his grandmother who got in the survey. So I'm looking at the ages, right? 75, 80, 92, 88. All of a sudden I find someone that's 8 years old. I can't delete them just because they're an outlier. However, if I go back and I look at the context and I see that person is, a student who was visiting their grandmother, that's not in my population of interest, so I can go ahead and delete them. We're going to talk about outliers a lot more, and outliers are very important, especially in business, and very few students really appreciate why they're important. Last but not least, we can have missing data values, and these are, like their name sounds, these are values of the variable for which we do not have data on a particular individual. What do we do with missing data values? The book goes into a long explanation, and while I won't argue with the book as to what they talk about and what they say, the reality is that most of the time we don't understand why the data is missing. And that's kind of the issue, how the data is missing. Was it missing because it was intentionally deleted, intentionally not put in, or was it just not recorded by accident? We generally don't know those details. Usually we do nothing with missing data values. And the software that we use, both Excel and StatCrunch, they ignore data that's missing. They just treat it as if it's not there. So usually it's not an issue for us. Okay, so why is this so hard? Okay, I mean, we talked about categorical, and categorical was kind of trivial to clean, right? Quantitative, not so trivial. And let me try to explain why. One issue that comes up a lot with quantitative data when you are looking at especially large data sets is this issue of whether a data value is an outlier or invalid. And I'm going to show you this example from this data set that you downloaded called iPads. And I'll give you a little bit of context on this, okay? So I'm going to go back here and look at this data set. And this is data that was collected on all US colleges and institutions that receive federal aid, which is the vast majority. The US government Department of Education every year collects certain data from every single college. And this was a data that they collected for the school year 2016. And what I want to do first is I want to look at the data values for graduation rate for 4 years. So this is the percentage of the students that graduated in 4 years. And I'm going to go ahead and sort that. So I go to data, sort. And again, I'm going to do it kind of quickly, but I do have a StatCrunch video that talks about it. I'm going to choose graduation rate for 4 years. It's the first graduation rate listed. And it doesn't really matter how you sort it. I'm going to sort it in ascending from lowest to from smallest to largest. And I see something interesting, okay? So let's go ahead and look at the lower values. So I have values where there's 0%. I'm going to have to worry about that. And at this end, I have colleges that have 91 and 92% graduation rates, and I have a lot of missing values. The missing values I can't do anything about, okay? And notice there's a fair number that are missing, and this is quite common when you're looking at very large data sets. It's not uncommon at all. What I want to do is I want to look at the data values that are very large, though. Are those suspect, okay? This is where you have to use a little bit of context, okay? If you look at these universities, and if you're not familiar with universities, this really won't make a lot of sense. But these universities are universities that are generally known for really good quality. Pomona is part of the is part of a special college in California. Okay, very high quality, very high graduation rate. Davidson is a very small private university. And so again, sometimes you have to know a little bit about context, okay? But all of these universities, Princeton, Boston College, University of Chicago, where I went, okay? These are all considered very high quality colleges. And so it's not too unusual to see these really high graduation rates. So sometimes determining if something is unusual or suspect requires a little bit of knowledge of what you're looking at. But in this case, there's nothing that strange. However, when we go to the lower end of the data values, there are potential issues. So first of all, can you have a college that doesn't graduate anyone in a particular year who started 4 years ago? That's highly questionable. Some of these we can kind of resolve. So first of all, if we have a small college, right? So this is the institution size right here. This is a somewhat small college, okay? It's possible. Notice, however, that for the 6-year graduation rate, it's not 0, okay? So maybe these are okay. Right? However, it's a little strange that this is 0 and this is 86, all right? So we could probably say that the ones that have 0 for 4 years, but they have a 6-year graduation rate, maybe they're okay. I still might want to check them out. The ones that are unusual are these two values right here. These are colleges that both had a 0 graduation rate for 4 years and a 0 graduation rate for 6-year students in the year 2016. That's highly unusual. So what is that? Is that an invalid data value? Is it practically impossible for that to happen? Or is it an outlier? And the answer is, I couldn't tell you. I have notions, I have ideas. This is a very small college, under 1,000. It's hard to say what that really implies, though. Maybe they just have very small graduation classes. What would you have to do? You would have to go back to the source, literally. You'd have to either call institutional research or call someone who's an expert in these sorts of matters and ask whether or not this seems reasonable. Now, why do I bring this up? Okay. First of all, I'm not going to give you a lot of problems where you have to sweat these sorts of really difficult situations, all right? Because you would just have to say, I don't know. However, when you're working with real data sets, there is sometimes a temptation to automate data cleaning. So some people like to use automated data cleaning programs. And they work quite well when you know the data. When you're very familiar with the data, it's data that you commonly collect, you can use automated data cleaning. And I'm not talking about data sets of this size. I'm talking about data sets where you have millions of people in the data set. And then looking at it visually and looking at it, trying to pick out outliers and everything is hard. It's not easy to do. So when you know the data set well, you can automate data cleaning. However, when you have a situation like this, and it's a new data set, so in other words, you don't really know anything about most of these colleges, the majority of you. I don't know a lot about most of these colleges, okay? There's a gazillion colleges. When you're working with new data, you don't want to use automated data cleaning. You really do have to do it by hand. So this is an issue that's going to impact some of you down the road. Okay, what do you do with these sorts of situations, okay? Suppose you hit a situation, and in this case, I'll be quite honest with you. I don't know if it's invalid or an outlier myself. I really don't know. I suspect it's an outlier, but I don't know that for sure. And in fact, I don't know that for all 6 of those data values to a certainty. What would I do? Okay, first of all, you can do the analysis with and without and see if they differ by about 5%. So when you're computing values, which we're going to talk about later, and they differ by more than 5%, you would report both. If they don't, you'd probably report the statistic where you used the whole data set and you didn't clean it up. So that's one possibility. The other possibility is a very useful technique that's not used very often, unfortunately, and that is to use a trim data set. So sometimes people use what they call a 10% trim data set. And what that means is they sort the values and they take out the highest 5% of the values and the lowest 5% of the values. And they look at the middle 90%. I do that, for example, when I look at your student evaluations. I read everything very carefully. Some people give really bad evaluations. Do I discount those? No. They may be really good students. They may be very discriminating. Like Gordon Ramsay, for example, when he goes to a restaurant, he probably doesn't give most restaurants really high ratings. Why? Because he knows restaurants really well. He's an expert. So really good students who are very discerning, they might give really bad ratings, okay? But that may not be the typical student. So I look at that and I think about that. And there are, on the other hand, there may be students that just give really high marks just because they want to please me. So we all know that whenever you do a survey, there are some people that always give 5 stars no matter what, okay? So what am I interested in? Well, even though I look at those values and I take them into account, what I'm really interested in is the middle 90% of the data. So I'll take the ratings, I'll rank them, I'll do a trimmed data set, I'll look at the results with and without, and then if they're about the same, I'll usually use the trimmed data set actually. Okay, and it doesn't really matter. When they're about the same, you can use either one, all right? There are more sophisticated methods, and I wish we had time to get into them because they're quite interesting. The one that is incredibly useful is called bootstrapping. And so a lot of times even when we have outliers in a data set, when we know for a fact it's an outlier, we use this technique called bootstrapping. And with bootstrapping, what we do actually is we take samples of our sample. It's a fascinating method. And it's one that people use a lot in modern data analysis. If we have missing data values, sometimes people use imputation. They try to fill in the missing value knowing other information about that individual. And again, we're not going to have time to get into that. It's beyond the scope of this course. Okay, that's all for this video. I hope you enjoyed it.